Hi, this is Anna with the last video of the module Wave Optics for the course ECE 513 Intro to Optics and Photonics. In this video we're gonna describe the experiment double-slit from Young. We're gonna introduce or we're gonna derive how the total intensity distribution changes in the double-slit experiment, and we're gonna deduce the condition for constructive and destructive interference in terms of the separation between the two slits and the observation plane. So the double-slit experiment is the one really showing that the light was acting as a wave versus a ray. And the reason was that what it was happening is that we were illuminating two infinitesimal slits or holes, and then we were generating secondary waveforms. So X1 and X2 were point sources coming from the original ray that they're gonna emit each of them a spherical waveform. So we were having the superposition of two spherical waveforms superposing in an observation plane on a screen. And what we're seeing is that the intensity was changing in terms of the location where we were observing every point. So we were having patterns of maximums and minimums about it. So we are having here two slits or two holes, right? That they are separated at distance 2a, and they are infinitesimal, so we are creating a point source, and each of the point source here it's gonna generate a spherical waveform. And now at a distance d, really far away compared with the separation between the two holes, we're gonna have here our observation plane or our observation screen. And in particular we want to see what's going on in a particular point. So here we're gonna have the path traveling for one of the wave, and here we have the trough traveling for the other one of the waves. So here we have, let's say here we have R1, so that's gonna be the distance from the first point source to the observation point. And now here we have our distance R2, which is gonna be from our second point source to the observation point, right? And the idea is that D is so much bigger than 2a. So that means, like, if we were tracing here a 90-degree, these two distance from, and let's say here we call this as our point B, so we can write the path traveling by the second wave as from S2 to B plus S2 to B. So if we see the ratio between them, right, if we make R1 minus R2 the modulo square, we know that this is gonna be the only difference between the path length, the optical path difference between both waves. It's only the distance S2 over B, and that distance for D values really far away compared with the distance between the two holes, and the two holes are infinitesimal, are smaller, can be approximated, or it's gonna be 2a over D. And this is through trigonometry. So what we are kind of seeing here is gonna be this distance delta, our divergence angle, and this separation of the optical plane, this is gonna be our optical path difference, right? So we know that the phase is 2 pi lambda are optical path difference. So this is going to be 2 pi lambda 2a over d, right? So when we are writing our resultant intensity, that's going to be both of them are illuminated with the same intensity. So both spherical waveforms, they have the same intensity. So that's why we have there 2 I sub 0. And then here we have 1 plus cosine the phase. But now we know that the phase is going to be 2 pi lambda 2AD, changing along the x direction. So here we are assuming that this is going to be our x direction. So we have our intensity, right, that changes following a cosine along the direction of the perpendicular direction of our observation plane, and we need to define what is going to be our constructive interference. So every time that we are talking about constructive interference means that the resultant intensity is maximum value, and that means that it's only going to be maximum when the cosine needs to be equal to 1, right? In fact, the maximum value is going to be 4 times the intensity of the origin. So the cosine is equal to 1 if the argument of the cosine is going to be a multiple of 2 pi, where now m is going to be any integer. So we can find here that the location of the maximums is going to be, like, you see that 2 pi's, they cancel each other. So the location of the maximums are going to be m lambda d over 2m. And then if we want to estimate the separation between 2 consecutive maximums, we just need to do m plus 1 minus x of m. So this is going to be at the end lambda d over 2a. So this is going to be separation let me do, because are not any maximum, it's just 2 consecutive maximum. So what is going to happen for the destructive interference? So destructive interference, we're going to say that is when the intensity is minimum, and in fact it's going to be equal to 0 because both holes, they're going to transmit the same intensity. So that means that the cosine is going to be minus 1. So we have like the argument of our cosine now needs to be a odd multiple of pi. So this is gonna be now a odd multiple of pi. So that means that the location of the minimum are gonna be that 2 can go to the other side, so we have m plus 1 over 2 lambda d over 2a. So now the things that we are canceling is that one, and then we can kind of cancel the 2 if we write here 1 over 2. So this is gonna be the location of minimum values or of the condition for the destructive interference, and if we estimate what is gonna be the separation of the two consecutive minimum. That's gonna be the same. So same separation, or let me rewrite it in a different way. Minimums and maximums values are equally spaced. And that's what we see here when we upload it. If we replot the resultant intensity, then we have our cosinusoidal behavior, our cosine, where we can see that the minimums are located kind of like odd multiples of lambda d over 2a, and then we have like two kind of like multiples of 2 of lambda d over 2. That's gonna be our maximum values, and the maximum is 4 and the 0 is 0 because both holes emit the same intensity. So there are so many information about interference and Young experiments, so I recommend you, if you can, go to these 2 YouTube videos and learn a little more about it. Thank you.